to our second speaker, Advait Bopardikar, who is a machine learning customer engineer from Google, helping their clients implement AI at Google scale. He leads the Canadian cloud practice for machine learning and AI, and previously he was a managing consultant within the Watson AI consulting practice at IBM. He leads agile teams of data scientists and AI practitioners to help tackle problems for some of Canada's largest companies, from prototyping to production development, and his client experience spans successful projects in the financial services, healthcare, telecommunications, transportation, logistics, retail, and public sectors. Advait is a Vector alumnus and holds a Master of Management in Artificial Intelligence, which is a Vector recognized master's program, as well as a Bachelor of Commerce from Queen's University. Welcome, Advait.
Thanks a lot. So let me share my screen shortly, and we can get right into the presentation. Okay, hopefully that's coming through. Okay, so really what I want to discuss today is not necessarily a project, but more so rethinking the tool set that you're utilizing when it comes to various different projects. One of those pieces that I want to claim should be inside of your tool chest is AutoML. So, I think a lot of people are thinking, hey, I just went through a master's degree or I just got a PhD in machine learning. I don't want to use AutoML. I want to build everything bespoke. Like that's what I just spent years of my life honing as a skill set. But in reality, we have to recognize that data science as a general domain has a skill gap problem. The number of people who have our skill set is relatively minimal. The number of developers or business users in the market who don't necessarily have those skills is quite large, and the demand is going to be largely coming from those groups. And by demand, I mean demand for projects. So we need to do something about making AI more accessible to millions of more people. But at the same time, there's another challenge that we have as being AI practitioners, which is, well, we have this process that we have to go through when we're developing a project. So traditionally, you're going to be loading in your data, then you're going to go through a lot of preparation, you're cleaning the data, you're perhaps then going through the process of engineering brand new features, and then you're doing the actual sciencey bit, which is let's create a bunch of different models. For each of those models, there are various different model architectures. For those architectures, there are various different parameters. We need to train those models, and then potentially we are then going to ensemble those models if we see that as the best path forward. So the amount of time spent in this iteration cycle is just way too long before you can even get to deploying and making prediction. In reality, it's something about 78% of models never even make it into a production environment, meaning that a lot is getting lost in the long lead times of this little science experiment that we're running. So it takes clearly way too long to do this. We have a long laundry list of projects that are often coming up. And oftentimes you'll realize when you're working inside of organizations outside of the research realm that you're being given a lot of non-data science tasks where you may be doing something like BI and reporting, where you're just doing SQL queries because the business users don't necessarily have that skill set. So we need to do something about minimizing a lot of these low value tasks and start focusing on higher value ones. And AutoML is just a single tool that can help in that process. So now the workflow changes. You still have the loading data set, but instead of going through that model cleansing and evaluation and testing process, you're really just setting a training budget and you're allowing AutoML to do the rest for you. Once it's done, it'll deploy it to a scalable endpoint. So you're now ready to make predictions. So even some of the pipelining and engineering around creating a scalable serving infrastructure is removed. So some of the benefits of using an AutoML-like approach is it provides a level of transparency. It'll provide you information about feature importance. It'll provide you your model evaluation metrics that you would want to otherwise look through. And this is really where a data science skill set or a machine learning skill set is still relevant and important. Business users aren't necessarily going to be able to make some of these decisions without having a background and understanding how to interpret the outcomes. And it will still provide you information about the overall model architecture. So if you were to try to replicate it in some sense, you could. At the same time, it's also dealing with a lot of the pains of being a data scientist. So when it comes to engineering features, it's able to deal with a variety of data types, whether it be numerical, textual, categorical, dates, time, nested fields. And it's also going to provide guardrails for the common data quality problems you're going to run into. So whether that be about imbalanced data or missing values, it's able to do a lot of this cleansing for you, things that are otherwise time consuming and quite frankly, not the most fun when it comes to actually getting to a result. So what is really happening underneath the hood? And this is kind of the example of the Google's version of AutoML, but there are AutoMLs by many different providers. I'm not really doing a sales pitch here. It's more about the general concept. Underneath the hood, it's evaluating multiple different models inside of our portfolio, or what we call a model zoo. So this could be simple linear logistic regressions, but that could be all the way up to something far more complicated, like a neural network, a wide and deep model, recurrent models, transformer-based architectures. It's really looking through, based off of the distribution of the data that you've provided, which version of these models is going to work best. Now, one of the other powerful things about AutoML is the fact that it's applying cutting-edge approaches when it comes to actual model development. So one of the things that happens inside of Google's version or flavor of AutoML is neural architecture search. So you load in your data, you are then going through a recurrent process to iterate on which model architectures and hyperparameters should be selected given the distribution of that data, and coming up with an optimal approach rather than exploring every permutation and combination of hyperparameters that exist out there. So when you compare this to a Bayesian hyperparameter search approach, or even certain bandit-based approaches, what you're finding is that the hyperparameters optimize at a much faster rate, meaning that you're able to get a model that is high quality, as well as using far less compute resources and time, and deploying it into production far faster than you would if you had done it by hand. So internally at Google, we use neural architecture search quite often. What we're finding is we're able to beat many benchmarks in terms of, in this example, ImageNet for image classification, compared to what were otherwise hand designed, so things like InceptionNet or PolyNet. We're finding that a neural architecture search approach is able to get models that perform better, even though it was done with relatively no human intervention. Here's a bunch of labeled data, and we kind of let it do what it needed to do, and we're getting results that are much better than what was happening at state of the art back in 2016. And now when you start thinking about, well, what else can I apply this for? In this one example, we went to the Mercari Price Challenge on Kaggle. Over the course of about an hour, you start to get into the top 800 or so rank. After 12 hours, you're getting into the top 500. After about 24 hours, now you're starting to edge into the top 100 rank of a Kaggle competition. And for those of you who have played around with the Kaggle competition, you probably noticed that the difference between the guy who came first and the person who came 100th, the difference is relatively low. So when you're talking about practical applications and really getting something out as quickly as possible, maybe that's serviceable enough for a real world application where your goal is not to publish the state of the art in a paper. Your goal is to do something that's practical to solve a business problem. So maybe before we quickly jump into a demo, the idea that I'm really positing to you guys is that AutoML as a tool set is allowing you to do a certain level of time and resource allocation, where you have many different projects. You don't have enough time to deal with every single project. AutoML can establish a single baseline for you to say, is it worth my time to explore this problem further, or can I move on to a new problem or a new model challenge or a new task that needs to be resolved, meaning that you can use it as a quick way to prototype and figure out where you need to spend time. If you have a small data science team, which is almost all data science teams, you're probably understaffed, this becomes a key piece of how you actually maintain and manage your day-to-day activities. So how simple is this workflow for AutoML? Well, it's quite simple. Step one is you load in your data. That can be a CSV file. It can be inside of your data warehouse. Then you go into the actual training step. So in the training step, you look over your data. You can quickly look at some feature statistics about the distribution of that data. You can set certain features to be nullable or change the data types that they show up as. So in this case, text can be changed to categorical. The data set I'm using in this one example is just the canonical Titanic data set, so a classification problem. And really after that, all you do is hit train. And you'll eventually get an email, and that email will say that your model is done training, and you'll be able to review your model evaluation statistics. You'll be able to see your AUC curves, your accuracy of the model. You'll be able to see your confusion matrices, as well as feature importance. So in this case, it seems like sex was the most important determination in terms of if you survived the Titanic, which makes the movie make a whole lot more sense. And then finally, once you're ready, you can go into the process of testing and using. So you can deploy with this click of a button that model. You can either export that model as a containerized object for local prediction, and then you can test online predictions as well. So now the challenge of MLOps, scalable deployment, serving, parameter serving, all of that is dealt with on on the cloud. You really just have to focus about getting your prediction results. So with that, hopefully that was a quick and short and sweet introduction in terms of how AutoML works and why you may want to utilize it. I guess I'll now open up to a couple questions.
Great, thank you for your presentation, Advait. So maybe we'll start off just talking about some of the different types of use applications that AutoML has in your everyday works. If you could give a few examples, I know there's confidentiality involved, but perhaps just a high level in terms of maybe the sectors it's applied to, as well as the types of clients.
Yeah, so I guess let's start maybe with the breadth of capabilities that AutoML can provide. So when you're talking about tabular data, you can do classification, regression, and time series analysis. When it comes to image or video data, you can do classification, image segmentation, object detection. And with NLP, you're able to do entity extraction, sentiment analysis, and classification as well. So from the number of tasks you can tackle, it's quite broad, meaning that when it comes to industry application, it's quite broad as well. We have clients that are in retail that are doing it for demand forecasting. We have customers who are in financial services that are trying to do fraud detection. We have autonomous vehicle companies using AutoML to try to build image segmentation models for the sake of training their autonomous vehicles. So as a general product or capability, it's applied quite broadly. At Google internally, it's an approach that's applied for multiple different use cases internally. We're often not doing everything by hand. We're using neural architecture search. We're using different hyperparameter tuning algorithms and auto TFX to actually productionize our models. Not everything is done in a Python notebook from scratch every single time. So the breadth of application is quite broad to pretty much any industry you can think of. It's more about the fact that we're giving you a core fundamental capability, and it allows you to plan how you should tackle certain problems depending on the size and the skill set of your data science or analytics teams.
Great, thank you. So you've talked a little bit about the benefits of using AutoML. What are some of the challenges you may anticipate when using such a software in data science?
I think the biggest challenge is that, well, two challenges. One is that it does have a constrained scope, right? I mentioned the types of problems it solves. There are certain bespoke problems that AutoML does not solve, right? So you're going to be creating something from scratch there. So the number of research papers where the state of the art is resolved by AutoML, probably going to be low. The other challenge I think that it has is it disillusions, or rather, it gives far too much confidence to non-technical users in terms of how easy it is to think about machine learning. Right? It's really not as simple as let me hit train and great, we don't need to hire data scientists. That's not the insight I want to share, nor is it really the perspective of AutoML. Understanding your models, understanding the data, understanding biases inside of that data, those are still tasks that a data scientist needs to review. And perhaps you need to also start thinking about, well, let me create an AutoML model, let me create a bespoke model, and let's test this in the wild, right? Let's split the traffic that comes to a prediction endpoint and see how well both things fare in the real world. So we want to make sure that organizations don't think that AutoML is a panacea for every machine learning problem, because it's not.
Right, thank you. So another question we have is, how do you see the tool democratizing such a specialized area of work?
Sorry, you cut out a little bit at the beginning.
Oh, sorry. Another question was, how do you see the tool democratizing such a specialized area of work?
I see it democratizing in that the number of, let's say, people who are business analysts who maybe have some level of statistical background are astute in terms of understanding data, but just do not know how to build a model from scratch. That's one opportunity where it simplifies or rather it broadens the number of people who can actually utilize machine learning. One of the other benefits of an AutoML is it can be triggered just using standard SQL in your data warehouse environment, right? So if you're a data analyst who knows how to do a bunch of BI, they want to consume a model that a data scientist has created or create their own model inside of their data warehouse, they can do that. And it also enables a whole lot of data hygiene best practices in terms of security and compliance when it comes to data exfiltration.
Great, thank you. And I think we'll take one last question from the audience for now. Pranav asked, as most of the data scientist data is being done quite well by AutoML, do you think AutoML will be used more as the only way of solving problems, rather just probing as to whether the project is feasible or not?
At least at the moment, I don't see it as the only way to do data science. As I mentioned, it cannot solve all problems. It is limited in terms of the types of problems it tackles. So there is always going to be a space for machine learning engineers and for bespoke data science. It just simplifies some of the more rote problems that you would otherwise need to tackle, right? There's always the demand forecasting task. There's always the fraud detection task that everyone is doing. Perhaps we can get AutoML to the state where it's good enough that it becomes a commoditized approach to that problem. But there are something that is really novel, something that's going to be a differentiator for a business or an organization or for society as a whole that is going to require real focus to solve.
Great, thank you, Advait, for answering all these questions.